Here's the summary regarding loading word from memory and storing word in memory. Here T1 is the destination, T2 is the base address, and 4 is offset relative to that base address. Similarly, store word in memory, T1 is the source register, T2 is the base address, and 4 is offset. In MIP syntax, it's not uncommon to see offset 0, which basically dereferences this address and takes you to the memory location specified directly by this register. This way, using the parentheses around the register, tells the assembler that the register contains an address in memory, and you just have to specify some sort of offset outside the parentheses. So 0 is okay to use. So in addition to this so-called basic addressing mode, which is accomplished by a single instruction, we also have pseudo addressing modes, which expand the syntax for programmers' convenience so that you can use labels as your source for loading information from memory and the destination when saving it. Corresponding instructions also exist for loading and saving smaller integers in memory, such as byte or half word. There are two versions of these instructions, and the reason for it is that we're always loading a subword size integer into a 32-bit size integer. So for example, byte could hold a small number that can be positive or negative, and when it's loaded into a register which is 32-bit size, if your data type is a signed integer, then of course you need to take the signed bit from here and sign extend it all the way to the left. And in case if your value is an unsigned number, so that you don't have to pay attention to the signed bit, everything is filled and extended by 0. Little Indian addressing may impact the order of bytes, so it's always required that you test your code and make sure that everything works as expected. And these are examples of reading subword values such as bytes. So in this simple code, we have 2 bytes allocated for a month and a day, and a 16-bit integer for a year. Here we take the address of the date and use it to load the month into a register. Then of course the address of the next byte is 1 byte away from the beginning of our date, so we say date plus 1 and we load another register and we get this day from memory into the register. So then we use LHU, and notice that U suffix of course used for unsigned integers, only zeros and positives. And here our year is 2 bytes away from the beginning of our date structure in memory. Another example is this string, which is storing 4 bytes with 0 terminated character at the end, and we load individual characters again using the label as offset in memory and then adding offsets 1, 2, and 3. So this way we get access individual characters in our string located in the data segment.